Let's solve problem number 8 of your exercise 2 from the successive differentiation. So let's start solving this. So solution of this problem is what? तो यहाँ पर क्या है? We have to find the nth derivative of x की power n and 1 minus x की power n, and that expression should be in the RHS of this type. Okay, so we have to find that. So basically, we have to find the nth derivative of x की power n and 1 minus x की power n. We have to find this, okay? And that expression should be in this form of the RHS, है ना? RHS type का हमें find करना है. So we know that by the Leibniz rule, we know the nth derivative of two product functions u and v, So कैसे होता है? We have this is u and this is nth derivative of v and plus nc1, and this is the first order derivative of u, and n minus 1th order derivative of v, and this is your nc2, and this is second order derivative of u, and this is n minus second order derivative of v, and so on. And this is your in the last we have v, and this is nth derivative of u. So the derivative order increasing in u and decreasing in v according to the binomial expansion. Okay, so to get this expression, we will have to think a little bit. ये expression, because in the last they are tending to infinity. So here we will just take u as this function and v as this function. Okay, then you will get this expression easily. So first you see the expression, आपको एक्सप्रेशन देखना है, देन यू कैन जस्ट रिकॉग्नाइज कि हमें किसको u मानना है और किसको v मानना है, बिकॉज इन बोथ द functions x power n and 1 minus x power n both are the degree of n. Okay, so we are just choosing u as this 1 minus x power n and v as x power n. So now, so this implies by Leibniz rule, we just apply the Leibniz rule. This is x power n. I'm not changing the order. I'm just taking u and v. So this is your u and this is your v. According to the, we expand it. Okay. So u means 1 minus x power n. So this is 1 minus x power n here. And this is nth derivative of x power n. And then in the second term, nc1. And this is a first order derivative of 1 minus x power n. And then the n minus 1th order derivative of x power n, and this is nc2, and this is second order derivative of 1 minus x power n, and you can just have the n minus second order derivative of x power n, and so on. Okay, and so on, we will do like that. Okay, so this implies the nth derivative of x power n, and this is 1 minus x power n will be becomes, so here 1 minus x power n is okay, and the nth derivative of x power n becomes factorial n, because we know that the nth derivative of ax plus b की power m is just equal to what? M minus 1, m minus 2, and so on up to m minus n plus 1 and a to power n, and this is ax plus b to power m minus n. So this was the nth derivative of algebraic function ax plus b की power m is this. Okay, so according to that, if we just differentiate x power n times, we will get only factorial n. So here we have only factorial n. I'm just here we have only factorial n. Okay, and next here this is nc1 means n, and the derivative of 1 minus x power n will be n 1 minus x की power n minus 1, and 1 minus x का further differentiate होगा तो you will get minus of 1 here. Okay, and then derivative of this, so we clearly see कि this will be where n, and then n minus 1, and these terms up to we will go up to n minus of n plus of 2. Looks like this. Okay, we will go in this way, and this x power n minus of n minus 1 will be remaining. It means plus 1 is remaining. Okay, so this is the second term, and then in the third term it will be n minus 1 divided by factorial 2 divided by factorial 2, and then this will be what is the second order derivative of 1 minus x power n. So it will be from here, this is the first order, for the first order derivative of this. So you are differentiating it again. So when you differentiate, you will get n minus 1. Okay, and this is 1 minus x power n minus 2, and because minus 1 is there, again you will get 1 minus 1 again. Okay, so this thing will be get, and what is the derivative of this x power n? It will be looks like this is n minus 1 up to 3, because here we will get up to 3 2, here will be have we get 3. Okay, x square and so on. So this is the derivative of the nth derivative and at all. So now you can easily see in this expression we have the factorial n, and in this expression if you can also tell this as factorial n. Okay, and in this expression if you want this factorial n, you just multiply by 2 and divide it by 2. Okay, so this expression becomes the factorial n. Okay, so now you can take the some common. So what will be common? First factorial n. I'm taking the factorial n is common, and this is 1 minus x power n. I'm just taking common. So what is remains in the first term? It will be 1, and here will be negative is here, and you have this is n into n. It will be n square. And now for the pattern of the expression, you can easily just, because you can also say this is factorial 2. So here this is square of the, you can just also write this is 1 square if you want. Okay, so this is your, and we are taking outside 1 minus x power n, और यहाँ पर हमारे पास क्या है 1 minus x power n minus 1. तो एक वन वन माइनस एक्स पावर 1 माइनस एक्स से डिवाइड करना पड़ेगा एंड मल्टीप्लाई करना पड़ेगा. तो बिकॉज हमने 1 माइनस पावर एन बाहर ले लिया है, तो यहाँ पर हमारे पास रिमेन बचेगा अपॉन में 1 माइनस एक्स, और एक एक्स यहाँ पर है, तो इट विल बी योर एक्स अपॉन 1 माइनस एक्स. तो दिस टर्म विल बी रिमेनिंग, एंड देन प्लस this is n, and n minus 1 2 times, so you will have write n square n minus 1 whole square. And because the factorial 2 is here and 2 is here, so you in the factorial 2 you can just write 1 into 2, and here is also 1 into 2, so you can write like this 1 square into 2 base square, and you just took out 1 minus x power n, so here remaining is in upon 1 minus x ka whole square, and x square is remaining, so you can write x 1 minus x ka whole of square. So in this way you can just get the nth order derivative of this function. Okay, so by the using the Leibniz rule, 1 minus x power n is here. Okay, so you just get this is your answer. Okay, so thank you for watching, and keep learning mathematics from here. Thank you so much.